So, hello and welcome to our new tutorial. We will be creating a VR wave shooter, and we'll be doing so in Unreal Engine 5. So, this is a game where essentially the player will be in a shooting arena or a shooting gallery with a weapon of sorts, a projectile weapon like a gun, and they'll need to survive as long as possible against enemies that will be shooting back, and these will come in waves. The goal will be for the player to survive until they die. That can be adjusted, and that will be the essential game loop. So to achieve this, we will need to look at a couple of things. So first of all, we'll need to look at the basics of setting up a VR project with Unreal Engine 5. We will look at the beginnings and the basics of implementing custom assets, although we will be leveraging off the template, the starter template itself, because it is exactly what it's there for, and it is just the most efficient way to go about it. We will then be discussing looking at the game loop, so understanding the player experience, exactly what's going to be happening for the player, where they start, how they progress, and the end. For the sake of the enemies, we'll look at some basic enemy AI, ensuring that they behave correctly and that they actually have some agency to them to make it a bit more interesting. We'll also be looking at some basic pickups, mainly health and ammo to start, but we will be covering the foundations of such so that you may add on, make a bit more complicated, maybe some power-ups, shields, etc. We'll also be looking at the player scoring and the progression. So each wave, how does it get more difficult? What makes them more difficult? How does the player acquire points? Is it per enemy killed? Is it per wave survived? Etc. And then we can add in some music and some sound effects to make it a bit more interesting, a bit more engaging. And then right at the end, we will look at adding in the main menu to make it a bit more of a rounded experience. And we'll add in some widgets for the heads up display so that the player is able to track their health, their ammo, and their enemy kill counts. And then, of course, finally, we will be building and testing the game to make sure that it works and ensuring that it is as we wish it to be. So I look forward to taking this journey with you, and let's get started. Alright, so for the setup, we just want to make sure a couple of things are in place before we get started. So first of all, you'll want to go, if you don't already have the Epic Games Launcher installed, you'll want to go to store.epicgames.com. You'll want to go to the top right here where it says download. You'll want to click download, and you just pick a spot where you want to put the download, and once it is finished downloading, you will begin the install. Now, shortly after it has finished installing, you then open your Epic Games Launcher. Once inside, you'll be greeted with a screen similar to this. You'll want to navigate on the left hand side to Unreal Engine, and you'll want to go to Library. Click on that, and then inside here you will pick an engine version. Usually the latest one is recommended to use, so you choose that, you click install. It will then ask you where you want to put it, and you begin the download. And once that has completed, you will have everything you need to get started. Alright, so now that we have everything ready, let's look at setting up a VR game. So first you'll need to launch from your Epic Games launcher, Unreal Engine 5.2. It will first check some prerequisites and then it will launch. Alright, so once it has started up, you should be looking at a screen similar to this. If not, it might have started you on the recent projects. Then just move to games, and from here you want to pick the virtual reality blueprint or starter blueprint, starter template. And here with starter content ticked, pick your appropriate location, and then for this we can call it VR Wave Shooter and click create. And it'll then just begin initializing, it'll compile some shaders, get everything ready for you, and then it will open up. Right, once it has loaded up, you should be looking at a screen similar to this. This is the starter template. Just slow that camera down. This is the starter template, and we will be using this to begin our journey. You see it, we already have the guns or pistols in and a couple of things to interact with, and this will be a perfect start for our VR wave shooter. Alright, so now that we have gotten everything ready and up and running, let's start looking at some of the basic mechanics. So given that this is a VR wave shooter, one of the first things we're going to want to implement is some kind of damage tracking and health. So the easiest way to do this and to get the idea across is to make a dummy character that will initially simulate just taking damage and updating health. Alright, so let's go ahead and make a new folder. Let's call it VR Wave Shooter. This is where all our custom assets will go. And inside here, the first thing we will need is we want to create a blueprint class. We want to just make an actor, keep it nice and simple, and we will want to name it BP Dummy. We will want to make our dummy. And so let's just go and open that up. Now inside here, we only really want two things initially. We'll want some kind of static mesh to represent our actor, our dummy. So I'm just going to use a sphere initially. And we want some way for it to detect collision. And since this is just a normal actor, we will want to add a collision to it. And we can do sphere collision since we're using a sphere. And then we'll want to make sure that the sphere collision is big enough to surround the sphere itself. So let's actually change it so that neither of them are parented, so we can change their sizes independently. And then let's just reduce this size until it fits inside our sphere, our collision sphere. You'll see it's just the outline of the wireframe, and this represents our collision radius. So once that's been done, we go inside the event graph with the sphere selected on the left hand side. We'll want to go down and we'll want to look for on component begin overlap. This will then fire off every time something overlaps with our collision, our sphere collision. And what we want to do is the first thing is we want to set up an interaction, just a basic interaction with projectiles in our game and objects that they can damage. So one of the easiest ways to do a damage system, especially in something like a VR wave shooter or any wave shooter, is the projectiles fired by the character, the main player, have a specific tag, and whenever those collide with something that can be damaged, they'll be checking for that tag and they will do damage. And that way, you only need to change the different enemies. So you can have different enemies, but you don't need to change it every single time for the projectile instead. You can use the same logic. So what we'll do is we'll say other actor, and we'll say has tag, and you'll see this actor has tag pops up. And it's just a simple get to Boolean. And the tag we'll want to use is projectile. And obviously you want to double check and spell that correctly because this takes that string as is, or text as is, and checks for that. Should this be true, We will then go into a branch. So if that is correct, we're going to want it to affect the health of this character. So we will want to make a variable for that health. So let's just call it health, make it a float, and we will want to make sure that we are adjusting the health should it be impacted by a projectile. So easiest way to do that is you can take the health, you can do a subtract, and for now we'll just choose a flat amount. So let's say we can assume the projectile does 25 damage each time, and that will be the state of the new health. Now, of course, you can make it so that different projectile types can do different amounts of damage, etc. But for now, just to keep it simple, we're going to have it that it does a flat amount of damage. And of course, we want to make sure, let's remove these, we won't need these, that we are keeping an eye on the health, so that should it hit 0, drop below 0, the actor will be destroyed. So we can simply create a branch from the event tick, and this branch is checking that health is less than or equal to 0. Now, of course, we need to set our health, because currently the default is 0, so let's choose something nice and round, like 100. And when, so it takes 4 hits, for example, when it is less than or equal to 0, we will then want to destroy this actor, like so. Alright, so now that with that done, we can move this over here, and we will want to go and find the projectile that is produced from the template pistol. So you'll see here, it's already in the template map as a demonstration. There is a pistol. You can click on it there, and then here, which is edit pistol, you can click on that, and you'll find the pistol. But it's not the pistol we want. It is instead, we want the projectile. Okay, so what we can do is we can then just go on the left-hand side here, look for VR templates. Under blueprints, we see the projectile. We'll double click on the projectile, we'll open it up. And now we specifically, with the projectile self, select on the left-hand side, scroll right down until we find a header that says actor. So here we go. We'll want to open this advanced tab, and under tags, we'll want to add a tag and name that tag projectile. So now when this projectile fired from the pistol included in the template collides with the dummy that we have created, it will then incrementally remove 25 health, so a quarter of its health, until it is destroyed. So you can go ahead and test that. So let's just go back to our folder, VR Wave Shooter, take the dummy, we'll just pop it in. Let's move it a bit back. And then we can go ahead, save, and give that a test. So pop on our headset and make sure that everything is running as it should. Alright, so now that we've established damage and health for a dummy character, just sort of the basics, let's go ahead and apply this to an enemy. So the first thing we want to do, just for a testing ground, is we'll want to go to File, the top, we'll want to open a new level, and we'll want to choose the basic level, and then click Create. Once that has been created, you'll be looking at something like this, which is essentially just a blank level. It's already got a floor and a skybox, etc. So just what we need to work with. Now, the first thing we want to do is, well, from your basics, at the little sort of the quick add drop down here, go to player start, just so that we have a place to start from. And then we will also want to make sure that the player is actually able to move around in this space. So from the same drop down, go to volumes, and you'll go to the nav mesh bounds volume, and you'll click, and it'll just add it to the origin here, or near the origin anyways. And what you'll see is that it's just sort of an empty box. But if you press P, it'll actually begin to show the navigatable or navigable area. And if I bring this down through the ground, you will see that this little green square pops up. And that essentially denotes where any controller, any AI, any pawn, anything with character movements essentially. So for this game, the enemies and ourselves can move. So we'll want to just scale this so that it covers a nice large portion of this map. Do so. Okay, that should be fine. Just shift it this way a bit. And for now, that is perfectly fine. I am going to press P just to toggle that view so that it doesn't get too confusing. And then we will want to begin working on an enemy. So, easiest way to do that, we go into our VR Wave Shooter, and we now want to create an enemy. The easiest way to do that, and leveraging off the existing starter content that Unreal Engine provides, we want to click on the add. We want to go add feature or content pack, and we'll simply want to import the third person pack. So select that and click add to project. And then once you've done so, the third person folder should appear here in your content. And you can go in and under blueprints, you'll find that there's a third person character. So we'll want to duplicate this. We'll be using this as our enemy and just say BP enemy character, enemy char. And we'll want to drag and drop this into our VR Wave Shooter and click move here. Now, if we go back to our folder, we will see that there is a copy of that. All right, so now that we've moved the character or the duplicated character to our folder, the character as it is has all the animations in. So just open it up. You can see it has this really cool, the new default mannequin. There's two, there's sort of a male-esque or a masculine and a more feminine one. This is Quinn, the more feminine one, and it already has animation blueprint applied. You can see the idle animation there. And all it really needs to be doing to this is giving it a couple of characteristics that will make it see or notice the character and actually move towards the character. So it's sort of a basic patrol and chase AI system. So first thing we'll need for that is we'll want to go and make it so that it just patrols generally. So the simplest thing to do is we will start with a custom event because we will want an event and we'll say move to say a random location. That's essentially what it's going to be doing. Okay, let's just zoom in a bit there, it's a bit small. Okay, and then for this move to random location, the first thing we'll want to do is check around the actual actor for an area that is navigable. So let's just go, or actually I think the easy way to do this is just type in navigable, and you'll see get random location in navigable radius. So we'll click on that. Now the origin is going to be this character's origin because it's checking from itself. So we'll just say get actor location, and we'll connect that up to the origin. Let's pick an appropriate radius. So for now, let's say 1,000. That should be more than enough. And this location, so whichever random location it selects, will be the location it is going to move to. So we then want to use an AI move to, okay, which is a built-in function which has some basic pathfinding and obstruction detection or collision detection, etc. And it also gives you option. You can move to a pawn, a selected pawn or specified pawn, um, a destination, an actor, etc. We are going to move to a destination or location. So we'll drag it from our navigable radius function into this move to, and it will then begin to move to that. Now we want it to patrol constantly or consistently as well. So once it has successfully reached this location, so you see this on success here, we will simply want to repeat this process. And the easiest way to do that is just to call the move to random location, this that we've created, and we'll just call it again over here. And now it will run such that while they are, so every time it runs, every time it's called, they will search in this radius for any random location that is navigable so that they can actually move to. It will then begin moving to that at whatever speed has been defined for the character movement. And then once it has reached that location on success, it will then repeat that process. Now, for that to be applicable, we'll want to make sure that this is actually called. The easiest place to do that is on the event begin play. So when this actor is introduced into the world and its unique begin play begins, we will simply want to, assuming all of this is valid. So what is important here, as you can see, it casts to player controller, whichever controller it uses. Okay, we have no issue with that, but we do not want to be reliant on that for its patrolling. So we will simply sequence it out so that it will still run that, and then it will do its move to random location. And we can save that. And if we go to our level and we drag and drop this character in, I guess it doesn't matter which way they face, and simply go to simulate, initially there will be no movement. So the reason for this is quite simply that for our enemy character, we want to make sure that the AI move has a self reference, so that the pawn, so that it knows that it is moving itself, essentially, that it has a pawn for reference. Leaving that out will return null, or return nothing, and then this will not fire off, and thus it can never succeed and will not continue. So we now run simulate again, and you will see the character simply moves from random location to random location. So that is the patrol down. However, that is, as interesting as it might be, is not going to be very useful on its own for our wave shooter. We want this character, enemy character, to be aware of our player itself. So to ensure that is the case, we first need to add something called pawn sensing. Okay, and what that will do, let's just go to the viewport to show you, is it creates this sort of detection area, that's the green lines, in which this pawn can hear, see, and essentially sense. So I'm just going to bring that down a little bit so we can see what we're working with here, and then that will also have a range over which they can see. So that's perfectly fine. We don't need to fiddle with that too much. But what we will want to do with it, with pawn sensing selected on the left, we want to go to an on-see pawn. So this is when it sees another pawn. From the on-see pawn, we want to drag it out, find an AI move to, and this pawn reference here, the pawn that it will see, will be the target actor, the location which it's moving to. And then as for our previous, or as with our previous AI move to, we want to get a self-reference for pawn. And then here, what's going to happen is as it sees it and it begins to move toward the actor, we are not worried about an on success now. We want to continue the function logic, and we want to introduce a retriggerable delay. So let's set this to 1 second. So all this ensures is that should, for example, this function not be running, or should, for example, for the context, the enemy not be able to see our character for whatever this is defined in here, so here 1 second, then it will return to what it was previously doing. So it will return to the move to random location, and this will stop firing. So you can set that to a higher amount. This also helps with things like if it actually catches up with the character and it stops moving, or the character disappears from view. This gives it a almost Assassin's Creed style guard detection kind of idea. For the sake of the VR wave shooter, it's going to be less useful initially, but if you want to do more complex maps, etc., the retriggerable delay can be very useful. So for now, we'll leave it in and we can refine that at a later stage. So following the retriggerable delay, we will simply want to just call again the move to random location, and we now have a patrol and chase loop. So while it cannot see the player character, it will be patrolling, so moving to random locations within a certain radius, and it will repeat this process until it is able to see the character pawn. Then it will begin to move toward them with a specific acceptance radius. Okay, that's just specifically how close or how specific that actually needs to be. You can change that to make them go right up to the character, or if it's a larger character, you don't want them to clip, for example, or collide with the meshes, you can change that as well. And then should this fail, so should there be no sensing of the pawn for more than a second, it will return to what it was doing. And that is the enemy AI at the most basic level. From here, we will then set up some interaction between the player and the enemy, initially just some melee interaction, and we will start to complete the game loop. Alright, so let's continue. And first of all, we've now implemented our enemy, and we have it so that the enemy will patrol generally, and should they catch sight of the player, they will then begin to chase. It's also important that the logic from the dummy, when we were testing the damage, etc., is transferred so that the character also has health, and on overlap with any projectile will take some damage. For now, I've just got the health printing out to screen so that I can very quickly, while in the developer mode, just quickly see that everything is working. And then here on the event tick, it checks for when the health drops below 0 or hits 0, and then it sends out a event dispatcher, which I've recently added, and then it'll destroy the actor. Now, what we're going to be covering in this video is very important, and this little event dispatcher here is quite pivotal to how it works. So we want to start implementing waves. We want to start actually getting the core structure of this game going. And one of the first things we need to do for that is we need to open up the level blueprint. Now, because there's quite a lot to this, I've already set up the logic and I've just commented it. If you are unsure how to comment, you just highlight and then you press C, and then the comment will pop up, and I've got it so that it's a bit easier to follow. Don't want to make the video too long, and most of this stuff is pretty straightforward at this point, so we'll walk through it, and this way I think it'll be more succinct and concise. So first of all, we want to have a few variables. So on the left hand side here, we have a wave number, so that's just going to track which wave we're in, the number of enemies remaining in that wave, and then the max number of waves we want the game to have, so that it doesn't just continue forever. Now, sorry, at the begin player, we will set the wave number to 1 because it'll always start at 1, and then we call our wave spawn function. So now what this is we need essentially 3 main functions, and I've separated them to 3 to make it a bit more modular should you want to change anything. We need a wave spawn, so that's actually going to handle which wave we're on and how many enemies there'll be. We have a wave advance function, which will tick the wave forward, so every time a wave ends, the wave advance function will move on to the next wave. And then the spawn enemies will actually handle spawning the enemies for the wave based on how many enemies we want. So the wave spawn is the first thing that's called, as you see here in the event begin play. And I've only set it up for 2 waves currently, just so that it is clear and not too confusing. And we've got the function so that it takes an input of wave number. So wave number 1, it'll then switch on int, so it'll look for 1, and we've set it so that 1 has 5 enemies, and then we will spawn those enemies based on that variable. Wave 2 will have 8 enemies. We will spawn the enemies based on that variable. So if we go to spawn enemies down here, you'll see that we have a for loop setup. And this for loop runs as many times as there are enemies. It's important that the first index is 1. Typically it starts from 0. That'll always give you 1 more enemy than you might think. So ensure that the first index is 1. And then in the body of the loop, so I've got an enemy spawn just to initially check that it was spawning correctly. And then similar to how the enemy character actually finds an area to move and patrols, we use the get random location navigable radius based on a spawn point. So we'll come back to the spawn point now, but it's essentially just going to be a very simple actor that we place somewhere in the level, and that's where our enemies are going to spawn from. And because we're in the level blueprint, we have a reference to that spawn point inside the level. Once it has found a random location that is navigable, it will then use that location to spawn an enemy or an enemy character. It will then take the event killed, or sorry, the enemy killed event, and it will bind it to a custom event inside the level blueprint. So that ensures that this blueprint, or any instance of this blueprint, when killed, will be able to communicate via the call enemy killed or the event dispatcher, be able to communicate with everything else on a global level, and when that is received, then enemy killed event will run, and the number of enemies will go down by 1, and then I've just got that printing that out. This is all the print string is very useful for when you're um, first setting up the logic, you want to debug. It's a good idea to know which parts are running and which parts maybe aren't running, where you're getting stuck, just to speed up the debugging process should you have to do it. And then once the enemy is spawned, it begins the move to random location. This is just to ensure that they don't spawn and stand still or have any logic errors. We want to spawn the enemy and move them to random location. And this will run for however many enemies. So if it's 5 enemies, it will run this section of logic 5 times. It will go to the spawn point, check around the spawn point, find a location that's valid, spawn that enemy, make sure that that enemy has assigned its enemy killed to something that will decrement the enemies left over here, and then it moves on to the next enemy and so on and so forth. This all happens in a couple of milliseconds, but this then handles that. And what's nice about this is whenever you call spawned enemies, you just change the number of enemies you want, and it'll run this as many times as enemies that you've requested. Now, two things I quickly want to discuss. So the spawn points, we'll very briefly cover this. I've just got it as a essentially empty actor with a sphere inside, and it just has the name spawn point. There is no code or logic inside. It doesn't need any of that. All it needs to be able to do is be in the level already, and then this basically is just a marker for where I want the enemies spawn. So if I move it over here, this is where the enemies will spawn around, to there, and so on and so forth. So super, super simple. It's just a nice way to have a spawning location that you can move around if necessary. Maybe you start adding structure to the level. You want to just spawn inside a certain area or outside a certain area. That's an easy way to do that. And then the second thing, and this is super important, in your enemy char blueprint, click on the actual root there at the top. And on the right hand side, you can search it or you can scroll down to it. Searching it is usually easier. You want to search, so you can just type in auto, but you're looking for the auto possess AI in the pawn, under the pawn header. And it's super important that you change this to, so traditionally or default, it's either at placed in world. You want it to be at placed in world or spawned. This will allow you to, once spawning the enemy, for it to immediately um, bind to a player controller, and it'll be able to start doing what it needs to do. It'll start actually acting with AI. If you don't change that, what'll happen is they'll just spawn in and they'll do essentially nothing. They'll just stand there. So that's super important. And I've even got it here in red text. So if you download and use this data or this code, you'll be able to see, and it's an important thing to remember. But everything else here is as it was. I've just tidied it up a little bit, which I always recommend. So that is it for that. And then these are for our waves. So you can have it so that when so I've got in the event tick, so it's the next thing we can discuss. We are checking for enemies left. We are checking that for when it is less than or equal to 0. You always want to do less than or equal to instead of just an equal to, in case there is instances of maybe at a double decrement or something like that where it goes into negative and then all of a sudden it won't fire off. So anything that is 0 or below will bring back true. And then we want to make sure that our wave number has not exceeded our wave max. It can be equal to, but it must not exceed it. If both these things are true, so there are still waves left to go and all the enemies have been killed, we then move on to the next wave. So over here, we've just got an AND. So how an AND works for Boolean logics, quite simply, is if either of these are not true, it returns not true. Only if they are both true will it return true, in which case we then move on to the next wave. I have a do once because this is on an event tick. We don't want it to try and advance waves a lot at a time. So we simply have it as a do once. It advances the wave. We give a short delay, which is sort of just nice, good practice to keep things that might be running concurrently to run in a way that doesn't clash. A short delay, and then it goes back and it resets the do once, allowing it to run again. Now, what's important is the reason we can do the reset straight back in is because in the wave advance itself, it then changes the wave number and it calls wave spawn, which will immediately change this value here, and it will need to move, the event will have to move all the way through it again before it can call the next wave. So in this case, it'll go from 1 to 2, so we'll go to number 8, and then we'll move forward. So let's just quickly test that out. So all we're going to be testing is, I'm just using the first person blueprint very quickly just so I can show you on screen without having to go into the headset itself. If I press play, you'll see they all spawn and they start moving toward me. If I shoot and kill them all, the next wave immediately spawns. Now we'll probably want to have a delay or something like that, but the basic mechanics are there. We have now successfully implemented waves in our game. So let's quickly just walk through what we did again. So we made sure that we have variables in our open level blueprint. So again, to recap, to find your level blueprint, you click on this little button here, this sort of graph. You find open level blueprint, and then it'll take you to the blueprint that has the same name as the map you are using. We have variables for wave number, enemies left, and wave max, and we use these variables to then actually begin to move through the waves, beginning with first actually in the event begin play setting the first or the wave to the first wave. We then spawn from that wave. When we spawn from that wave, it checks which wave number it actually inputs. So in this case, wave number 1. It'll then spawn an appropriate number of enemies for that wave. For now, we enter that value. And then once it's gone through and it runs to the for loop and it spawns the number of enemies that we have asked for it to, it will then keep track of those enemies until they are all dead, at which point it will advance the wave, moving it 1 forward, and it will run the wave spawn again. So I hope that makes sense. That is the waves part of this logic. Next up, we will be focusing on making the enemies do damage to us as well, and a bit more of the player difficulty, player progression side of things. Alright, so we are back and we are now going to be taking a bit of a look at damage to the player. So we've done damage to the enemies, we've done dealing damage to the enemies, but also we want to make sure that there is actually consequence for the player, and that is will be done in the form of contact damage. So the simplest way to deal with that is we go to our VR pawn, we open up our viewport, and we add in a collision capsule. You can use any collision shape. I just chose capsule because it's a bit it's more similar to what's typically used and the shape that we imagine our bodies will be. So it's a bit more immersive. And you want to add it so that it is attached, it is a child of the camera component, so that wherever the camera moves, it will move. You can also do it so that it simply is based on the origin, so you can attach it, and then what will happen is wherever you move as a player, it will move too. But the most important thing is that there is a collision capsule, and you can change it depending on how you want it to be affected. Now, when the enemies collide with this collision capsule, then we will have a on component begin overlap that will trigger. You can see I've just got the print string in here to see that it works, which I can remove now. But I like to keep that in, and I like to show that as part of the process. I think it's a very important part of the development process. It keeps things a bit more streamlined and makes debugging considerably easier. So when a component begins to overlap, it checks that the actor has a tag. So here we are using tags again, and specifically the tag enemy. Okay, because we're going to have different tags for different things that you can come into contact with. Later on, we'll have pickups, and this is obviously for taking damage. We're looking for an enemy. If it is an enemy, then we set a boolean called contact with enemy. We set that to true. And then when they leave the capsule, the overlap, ensuring it is has they have the same tag, we will then set that to false. Now that is important because in our VR pawn at the top we have an event tick, which is then handling our damage. So what's nice about the event tick is it comes built in something called delta seconds, and essentially the delta seconds is simply a variable that ticks with time. So you can use it to quite simply adjust things relative to time without actually having to, for example, create an internal clock or something like that. So here we're using delta seconds, we're just timing it by 5 to make it a bit quicker. And that is being minus from the player health, and then that is being set to the player health, and this is only happening while contact with enemy is true. So essentially when an enemy or an actor with the enemy tag enters that collision capsule, and well, once they've entered, this will trigger, and it'll be constantly running down, constantly subtracting health. Then when they leave the collision capsule, then this will be set to false, and then this will not happen anymore. And then underneath that, you can see we have a couple of things for our HUD. So let's move straight on to that because we want to have a way to show the player their health and how quickly it ticks down, etc., when they are taking damage. So now's a good time to approach and handle the heads-up display or the HUD. I made a very basic HUD here. It's using only the very simple, common, and primitive objects on the side, on the left-hand side. And I've put placeholders here for all the things that we're going to want on our screen. So although we haven't necessarily handled all of these yet, the one we're focusing on now is health. And health is quite simply, so this is just text, just to show that's health. You will notice that the font is quite large. It's important when setting up any kind of heads-up display, any kind of visual feedback for the players in VR that the fonts are large enough that they will be easily visible without getting in the way of the player's vision. That also being said, there is a perimeter of which that the field of view will actually not be visible or not easily visible. That's something you might have to play around with a little bit, depending on your headset as well, depending on the field of view that you play with. These might be changed or adjusted slightly, but generally speaking, the best kinds of UIs use very simple imagery and, if there is text, very simple text to communicate what it needs to. So the health bar is essentially two components. There is a background, which is just quite simply to show um, when the health bar depletes. And then there is the health bar itself, which is a progress bar. So everything here is nice and simple. It's drag and drop. You drag the text in for each of the different things. But for the health bar, what happens is you drag in your progress bar, which is this here, and you can set it as you wish. I set my anchor to the center, that I can center it or I can horizontally center it for the player screen. And then I have it so that it's sort of a margin above the bottom. It starts at full, so 1% here. I chose the color full and opacity to just be red with full opacity, and everything else I left the same. The only other thing you'll need to change is here at the top right under the details panel. You want to set is variable and make sure you give it a name that is easy to track when you are editing it in the graph. So let's head to the graph editing mode. Now in here, quite simply, I made a variable for health, or the health that it is tracking, and I divide that by 100 because you will notice, let's go back to the designer quickly, that when you click on the progress bar, its percentage is a value between 0 and 1. If you hover the mouse over the word percent, it will tell you in the tooltip that the progress bar is ranging from 0 to 1. So we need to make sure that our health is out of 100 typically. That's the way I've got it for my VR porn. It's between 0 and 100, which makes it nice and simple. So you just divide it by 100 and that'll give you the percent relative to the health bar. So by dragging the health bar from the left hand side here, you just drag it out, you type in set percent, and then you will have this function as there as above. Now this health value will be set outside of this blueprint. It'll be set by the VR pawn itself, but we need something to refer to inside the widget that can actually affect what you will see on the widget itself. And then we've just got the set text set up here on the right hand side. This isn't relevant just yet, but just in case it causes confusion, I've quite simply just got variables for each of these, which are all integers, and they just quite simply they take the integer and they set the text for the ammo count for the enemies left and for the wave number, and that specifically refers to the numbers here. So this is just text, and then these are the ones that will be changed. So you'll see at the top right here, that is a variable, that is not. The actual wave is not a variable, the zeros are, and so on and so forth. So when referring to the wave number, it's these zeros, enemies left is these, and ammo are these, just so you are all caught up. So let's go back to our VR pawn, and now you'll see that when I change the view, you can see that over here, there is a very small or a much smaller version of the HUD. Now, the size, space, distance, etc., you'll want to do it so that when you check on the VR headset, it makes sense. So, an easy way to do that is you just drag and drop the VR pawn into the world, and you'll get this little pop up over here. Now you just that'll pop up whenever you click on the VR pawn. Now what's really important about this is if you just use this, you might feel it's better to put the health and the different parts of the HUD lower down and push them closer to the edges of the screen. However, with the way that VR works, if that health sits at the bottom and the ammo sits at the bottom left, the player will be unable to actually see it properly. It will almost be curved out in their periphery. So this is useful for centering and ensuring that it is showing visible on screen, but be sure to pop the headset on every now and then just to test it out and make sure that it actually is visible and is comfortable to look at. So that's just a nice way to take a quick look and just to double check. So inside the VR pawn, so I put it there, I've checked it, I'm happy with it. I and just in case it comes up under camera, you go add, you say widget, okay, and then once you've added the widget, you go to the right hand side here for widget class, and then you select your widget class, which we have as the WB HUD, so widget blueprint underscore HUD. And then I just set draw desired size so that there are no clipping issues, and then I've scaled it down quite considerably so that it fits perfectly into the screen. So that's just about placement. Now that we've placed it correctly, we'll want to go into our blueprint, or our event graph rather, and we'll want to first call the HUD, okay, or we just called it HUD, so we'll want to call the widget, and we'll want to then use this get user widget object, which is always required when referring to widgets, specifically if you want to actually change anything inside that widget. And then we need to cast it to that specific blueprint. In this case, it is so to WB HUD, and on a success, so because the cast can fail sometimes for several reasons, but we won't get into that. On a success, we will then set the player health, which is the variable of the actual pawn, the actual health, the health that is adjusted when there's enemy contact. We will use that to set the health inside of the heads up player, inside the HUD widget. And the same thing for enemies left and wave number. So what's important is because the HUD has been attached to the VR pawn, we will need to set enemies left and wave number from the VR pawn, even though these values are stored at the highest level in the level blueprint. So that's super important because otherwise it's going to be quite a few steps to get to actually change these values on the HUD that we see here. So, and then I just also have a print string for cast failed for the debugging, and sometimes it's just super useful for some small issues, etc. I always recommend having that where possible. It's a lot like commenting in code. And that is all we need for the translation from the actual variables as they are in the game to the widgets or the HUD so that they can be seen by the player. So with that being said, the last layer we need to look at is the actual level blueprint, within which, and of course this is when we set up the waves where the enemies left, wave number, all of that is actually kept. We simply, at the event tick, we get a get player pawn. We cast it to the VR pawn because that is the player pawn that we will be using. And we, as the player pawn, we then just set the enemies left and the wave number using the variables within the level blueprint that are actually being used to run the game itself. And that is all we need for that. So that is the damage and displaying the health on the HUD. Next, we will take a look at setting up ammo and ensuring that the weapon actually can run out of ammo. And following that, we will obviously start looking at pickups like ammo and health and actually start to get a bit more of a robust game loop going. And then just before closing out, the enemies left and wave should also be displayed correctly because we do have the number of enemies left and the wave being set here, which are also referred to in the VR pawn over here and over here. And then, of course, these are taken from the highest level here in the level blueprint. So that should be set up as well, but that is very simple. That is just quite simply translating the variables from the different levels and different blueprints right down to the widget itself. All right, so welcome back. Let's take a look at setting up our ammo count. So this is going to be a little bit more complicated than some of the previous stuff we've done, because now we need to set up a couple of things, a couple of interfaces in such a way that the pistol, as it's called in the starter template, is able to communicate between the VR pawn, which it attaches to, as well as the level blueprint, which will be handling the ammo count and that kind of thing as well. So first we will start, let me just take the um, level blueprint, sorry, and the pistol. So let's just line these up and we'll get to the pickups just now. And okay, so first things first, for the VR pawn, all that is particularly important initially is that for the cast to the HUD, the widget blueprint HUD, we simply add in something that sets the ammo based on the ammo count, which is a variable, an integer, stored in our VR pawn. Because the VR pawn is obviously the player pawn that we will be using, and it is important for this that there is a pistol in the level. So similar to the starter template, the starter map, there are two pistols sitting on the table sort of thing just in front of you. And once you pick them up, they interface with the VR pawn and you can fire projectiles, etc. These are obviously the same projectiles we've been using to damage the enemies. Now, what's important is for the pistol itself, it has an enhanced input action. So inside the event graph, you find the input actions for both left and right, and you will see that, so the green is what I've added, but prior to that, once you press it, it checks if it's left or right, it finds the muzzle location, it spawns the projectile, and then it plays the haptic effect, the vibration. So what we are adding in is, first of all, we will need a variable that will check if there is ammo left or not, i.e. whether or not the pistol or the player is out of ammo. Assuming, or in the case that it is not out of ammo, so it does have ammo, so I phrase it has ammo question mark, so yes, it does have ammo, it will then call bullet fired. Now this is our event dispatcher. These are used to communicate from a blueprint to the level blueprint, and that will allow communication on a global scale. So we call bullet fired, which will then be referred to in the level blueprint, and then if it is out of ammo, we just play a empty ammo sound. I'm using the dockable window drop sound, which is included in the starter files. You should have it as well. And nothing else in the pistol needs to change. You see there's no green. This is the only green section here. So now we go and see where the call bullet fired is actually, referred to. And you'll see inside the level blueprint, here under event begin play, I've just detached this because I was testing it. This should technically be in there. But what we are going to do in the screen section here is we will take the event bullet fired, and on begin play we will use the pistol that's in the level, so we'll get a reference to that. We will assign this event or bind this event to the bullet fired event, which will fire off every time the bullet fired event dispatcher is called. So if basically every time you pull the trigger to shoot, it will run this. So the first thing it does is it gets the player pawn, it casts to the VR pawn because that is the type of pawn that we will be using, and inside here it will get the ammo counts, which as we discussed is housed in the VR pawn. It will first ensure that it is not greater than or equal to 0, so that it is more than 0. If this is true, if it is equal to 0 or less than 0, then we set it to has no ammo for the pistol, and we set the ammo count to 0 just to make sure that there are no issues there. So if you remember, the has ammo here, if that is false, then it will not fire the bullet. So we are making sure that we have checked it, and we now have seen that there is either 0 or below ammo left, so there's no ammo left, and we will set that value variable in the pistol. If there is ammo left, then we will decrement from the ammo count, so the amount of ammo that is in the VR pawn, and we will set that amount. So we will, let's add that in. So then we do this, we take that new amount, and we make sure that the target is the VR pawn. Let's just tidy that up, bring that down there. So now we have it so that every time you fire, if there is ammo left, it will take away from the ammo remaining. And if there is no ammo left, then it will not allow it to fire, and instead you will get the dockable Windows sound. So just to add on to that, I have chosen an ammo amount of 20, which is sort of relatively reasonable because initially there's only 5 enemies that spawn. They each take about 4 shots, but I plan to have pickups, which is the next thing that we will discuss. So now that our pistol has ammo and we're tracking ammo, and we understand that that is attached to that pistol specifically, or tracked by that pistol specifically. For now, we've set it up so that the VR pawn tracks the ammo, but if you were to have different guns, you could change it so that the VR pawn simply references the pistol, and that pistol has its own ammo. But this is a simpler method, and for the sake of setting up a basic VR wave shooter, this seemed the more concise method. So let's move on to setting up some pickups. For our pickups, in our wave shooter folder, we will make a folder for the pickups just to separate it from the other things we have. And then, so this is pretty straightforward, this is pretty simple, but it can be very, very useful. And it only remains simple provided you've set up your variables like ammo and health well enough that they can simply be updated via a single class or a single blueprint, which is what we have done. So let's look at the health pickup firstly, because it is the simpler one. So the pickup itself is just quite simply a sphere, which I've given a material with an emissive property, which we'll look at now, and a sphere collision around which it will detect when the player collides. And the only code in the event graph is the onComponent begin overlap. We check that a player has collided with it, so it won't activate if the enemy does. We give a brief delay. We spawn a little Niagara system, which is just to give it a bit of VFX, and then we destroy the actor because it's now been used. What's very interesting about this is none of this is actually responsible for what's going to happen to the VR pawn. What is important for that is that this actor has, under actor, as we have been using, 2 tags. It is a pickup and it is a health pickup specifically. So there will be 2 types of pickups. We'll have a health pickup and ammo pickup. And depending on which tag it has, will change how it interacts with the VR pawn. So let's first take a look at the material. It's very straightforward, but we haven't really looked at materials yet, so it's a good idea to just pop in. So I simply created a new material by right-clicking and selecting material here. Once I did, I opened it up. You press 3 on the keyboard and you click, and it is a nice shortcut to giving you a color, essentially a 3-channel color. So I use that, I just made it red. I attached it to the base color as well as the emissive color. Sometimes if you do emissive color only, it tends to white out a little bit because there is no base color, it's using the default base color. But I like to put in the base color, it gives a nice richness to the emissive property as well. You can increase the emissive color as well. And oftentimes, if you're going to making different versions of this, you will find that people will do material instances. But since we're only doing two materials, I simply duplicated it for the ammo and I just changed the color to green. And then in the ammo pickup for the sphere, you can simply change it to M ammo pickup. And now we have a green pickup for the ammo. The inside the ammo pickup, which again is just the sphere with the sphere collision, all that's really important, all that's important in the event graph is exactly the same. Nothing changes. It is just checking for a player. If so, spawns a specific system at the location and then destroys itself. We will change the system just now, but just to change the color. But otherwise, everything else is exactly the same, except of course noting that for the tags, we have ammo as our second tag rather than health. So now let's take a look at our system. So Niagara systems can become quite complex, but in the theme of keeping it simple, keeping it straightforward, this system is quite simply created by right-clicking, clicking on Niagara system, new system from selected emitters. So we want to base it off of emitters that have already existed. And we simply just choose an omnidirectional burst, which is exactly as described. It's a burst that goes in all directions. You click on that, you click the plus icon in the bottom right here, which adds it to the system. And then when you click finish, you will end up with exactly this. The only thing I have changed for this is that I have given it a, okay, I've increased the spawn count for the burst and I have changed the color mode on the initialized particle. Everything else is exactly the same, nice and simple. We don't want to change any of that. And this will run every time one of our pickups are interacted with. So for the standard one, I have red. And what you can do is you can duplicate this with Control D. And then for the second one, you can simply change under initialize particle, you can select green, a nice saturated green. Just click save. And then you can go and for your ammo pickup, the blueprint, you can just change the system that is here to the one that you just made. So mine is the NS pickup FX with the 1 at the end. That's the green one. Now, when it is collided with by the player, it will create a little Niagara system effect, and we will have that be a color that is associated with that specific pickup. So red for health and green for ammo. So now the last part of the pickups is how it interacts with the VR pawn. So if you scroll right to the bottom, back to where we have done the collision handling, on component begin overlap with the capsule, you'll see that we now have, so previously it was just enemy, added pickup, and then one for health and ammo. Now, there is a more succinct way of doing this, but although a little bit convoluted, this is a very nice way just to kind of visualize how the logical process works. So we first check for contact with enemy, assuming that is false. We are then checking for contact with pickup, and should that be true, we want to know if it is a health pickup or an ammo pickup. If it is a health pickup, we simply add 25 to player health. If it is an ammo pickup, we add 10 to the ammo count. And that's quite literally it, because we have player health set up and it is handled by the VR pawn. Anywhere else that needs to reference it references it from the VR pawn, which is the same thing that is picking up, in inverted commas, the pickups. We can quite literally just add to that when it detects it has picked up the relevant pickup. Same with the ammo. The ammo is handled by the VR pawn, which is why I said earlier we set it up this way, because it is much simpler than setting it up specifically for the different pistols or the different weapons. we have it so that it just adds to the ammo count. So that is pretty much it for the pickups as well as the ammo, and we are starting to get the core game loop going. So you can pick it up or drag it in, and you can dot the pickups around the map if you want. Just make sure that they are in a position that is able to collide with the capsule that you set up in one of the earlier videos. It's very important that uh, this capsule, however you've set it up, is able to collide with the pickups, because otherwise the pickups won't work. So we can go ahead and test this now. Make sure to test the pistol, your ammo count. It should be showing on your HUD at this point. It should go down as you fire, and should you collide with either the health or the ammo, we will get added to either our health or our ammo count. You might find that the health will go over 100. If that is the case, you can quite simply cap it so that when it is a health pickup and it is true, you first check. So you first check that the player health is less than or equal to 100, and only if that is true will it actually run the amount. So, well, actually, technically, I guess we want it to be, so you can cap it as such. You can also do it so that the amount, so it'll add, but it'll check what the total will be before adding to player health. So if it's going to be over 100, it sets to 100. If it's going to be less than 100, then it leaves it at the value it is, etc. Or of course, you can quite simply have it so that whenever the player collides, it just quite simply sets player health to 100. So it's a full heal every time, depending on the difficulty you wish to engage with the players. So that is all for that, and see you in the next video. Alright, so just a quick update or amendment regarding the pickups. So I've been testing it quite a bit, and as I got further into the development, realized that the pickup setup that we previously had, although it works, isn't the ideal version. There seems to be a bug or two with collisions in this version of Unreal Engine. So just to amend, you'll remember that previously we had, under the collision handling for the VR pawn itself, we had the logic tree that specifically checked for pickups, health, ammo, etc. What I've done is I've taken that away because there was an issue with the actual detection of it. So instead, what I've done is inside the pickups themselves, I simply get player pawn. So just to be clear, this is after the on component begin overlap, where you first check if it's a player. If it's true, it spawns the system, etc. I've added a sound, and then we get to the amendments. So we want to get player pawn, cast a VR pawn, which is the type of pawn we're using, and then we want to adjust the player health from this pickup directly. So for the health pickup, we're changing the player health, we're adding 25. From the ammo pickup, doing the same thing, but we're adding 10 to the ammo count. So just that amendment to note, and then we can move on. All right, so now that we've gotten to this point of the tutorial, let's actually take a look at completing the game loop. So let's have it so that when the player's health reaches 0, they will effectively die. There will be some visual feedback to show this, and then the level will simply restart and they'll get to run it again from the beginning. So the first thing we'll need for this is in the VR pawn itself, where the health is tracked, we will want to go to where we actually check for when the health reaches 0. So scroll right to the top, and you'll see I have this mess of code here, which we will be discussing and hopefully making a little bit more legible. or coherent. So we the first thing we want to do, and because this is what defines the end of the game, it should be the first in our event tick sequence. So remember previously we had the contacts with enemy, checking for player health. If it is true, minus health from the player, and then we do our HUD updates. So what we want to do now is we want to have a check for when the player health is equal to or less than 0, and then we want to run two separate things. Now, although this mess of code makes sense, there is a simpler way to do it, which is why I've left it, so that I can first discuss it and then I can show a way to simplify it. So first of all, if the player health is less than or equal to 0, i.e. the player is dead, we are going to want to disable input so that they have effectively died. It is important whenever affecting the input, we have to get the player controller first. We are then going to have a little death screen widget which will pop up, and we will hide the HUD, and then we will send an event dispatcher called player death to the level blueprint. So we will call player death. And should that complete, this is where the mess begins, it will reset the other do once. So how these do once clauses work is as it runs, so assuming it's not started closed, as your logic flow runs and it enters this function, anything that is after it will only run once. It'll run through and then it will close it. And then any additional firings will not fire. This is a nice way just to ensure that you don't have unnecessary extra ticks or functions running, etc., especially because this is attached to the event tick, which is obviously going to fire off every single tick. So the do once can assist with that. And typically you want to have something that just resets the do once. So the way it's been done here, because there are two do onces, if the player dies, okay, so reaches 0, then it calls player death and then it allows to enable input. Now, what we are going to do instead is when the player dies, we are going to restart the level, which means that everything that is set here is going to be reset anyways. So we can effectively remove everything in the false, because this is essentially the default state that it starts with. You start with your input enabled, you start with your HUD visible, etc. So we can simply remove that. And even this, although I'm going to leave the do once there, is somewhat redundant because once this runs, everything gets reset anyways. So that is just a nice way to understand that and to simplify that. So what I mean by we're going to reset, let's take a look at the call player death, and let's go to our level blueprint, and inside here, let's find under the event begin play, I've simply added it into a separate section here. Let's just comment this, handle player player death. Let's give it a bit more space. Make it green so it's easy to identify and that we know it is new. And then let's just pop the bubble up so it is easier to read. Alright, so in handling our player death, obviously the first thing we need to do is we need to get player pawn, cast it to our VR pawn, and then we need to bind the event that is being dispatched from the VR pawn. So left hand side here at the bottom, event dispatches. Let's minimize this. So our player death, when that is called, there needs to be something assigned to it. So right at the beginning of play, we will assign this player death event. Now, when that happens, we will simply change, we will have a variable. This isn't necessary, but it can be helpful to have a variable that tells whether the game is running or not. So here we have game started set to false, which just stops any of the ticks or anything that we do not want to be happening while the game is not running. There is a brief delay, so a 3-second delay, and then we run an open level by name. So the same level that we're in, we're going to open it again, which is effectively a very straightforward way of restarting the level. Um, these are the default settings, so don't worry too much about them.
We just want it to be that when this event fires off, so when the player essentially dies, there will be a brief pause, and then there we will restart the level. Now, the brief pause is mainly so that it's not so jarring, and also so that we have our UI, we give it time to actually make sense. So you create a new widget called, well, I've just called it widget blueprint death. And inside this widget, just very simply have a you died text, which is anchored to the center. So it'll always appear in the center of the screen. We have a respawning, and then a super simple circular throbber, which on the left-hand side under primitive, you can find here. And these two are just managed by this horizontal box on the left-hand side. So the horizontal box just makes sure that they are always in horizontal fashion with each other, or horizontally aligned, and then you can adjust their sizes, etc., or the order of them. I prefer it like this. So when the player dies, they will briefly see this for about 3 seconds, and then the level will restart and the HUD will be available again, and this will not be visible. Now, on the player pawn side or the VR pawn side, all we need to do here is previously the same way we had our HUD, we can quite simply just duplicate that. I'm going to change the name to death screen and make sure that on the right hand side under our widget class, we select the blueprint that we've assigned to the death screen. And if you are having issues with everything appearing together or overlapping, you can simply turn off draw at desired size. Sometimes it is useful, sometimes it is not. It depends on where on the Z order, where on the order or the layers rather, your widget will appear, and also what your widget is composed of. And then lastly, we want to go, so scroll right down, we want to find rendering. We want to look at visible, and we want the death screen to initially be not visible so that it can be activated or only shown in here in our event graph when the player health reaches 0. So this is where we set death screen, we go set visibility to true, and for the HUD, we change it to not visible. So basically just switching them. And that is essentially the player death. So all we really have there, or all we've really added, is so that there is now something that happens when the player dies. So we will have it so that health reach will reach 0, and the player will lose ability to control everything, and then they will meet with a death screen, and then after about 3 seconds, it will restart, and they will have another chance to go again. Now, quick quality of life thing. It can be quite jarring initially if everything runs immediately. So as you start the level, the wave spawns, etc. So adding a short delay, 3 seconds, sort of the general rule of thumb between 2 and 3 seconds. We have a short delay, and then we spawn the wave. So this allows the players to just initially get orientated, etc., so that it's not as they start the enemies appear. Small things like that can really improve the feel and quality of the game, especially from the player experience. Um, and then the only other thing I have is the game started. If this has not been included yet, you can simply add it on your event tick so that it acts as a sort of gate for the update. So we have this constant update, which makes sure that if there are no enemies left and we haven't reached the max wave, we then move on to the next wave. But we only want that to apply once we've started our game, which we begin here just before the waves spawn. Otherwise, anytime there aren't any enemies left, so for example, right at the beginning of the game, or if you want to have sort of breaks in between levels, this would automatically fire off and you would not be able to actually stop the wave spawning. So a game started clause can really help with that. And that is essentially the game loop. So now we have it so that whenever the player dies, they can restart and the game effectively loops. Right. So this should be a nice quick video. We're just very quickly going to look at adding a bit of feel to the game using music and sound. So first one, super easy right off the bat. adding music to the game. So the most important thing to note is that for any music, any sound, it's always a good idea to have a separate folder for it. And then you need to import it always as a WAV file or a WAV file. So I've just pulled a very simple ambient music sound that I have in my library from Epidemic Sound. And all that will do is you simply, once you've imported it, it just comes in as a WAV file. You can drag and drop it into the level. I already have one, which is right here. Once it's in the level, on the right hand side, you do have some options. You can change the volume multiplier, etc. But for now, as it is perfectly fine. It will start playing immediately. You can change that by turning off the auto activate. Um, and you can also adjust a couple of other things in the sound itself. You can make it loop or not. So your auto activate is on the right hand side in the details panel under activation. You can turn that off if you wish to. I'm perfectly fine with it sort of always being on in the background. And so that is music handled nice and simple. It is obviously possible to adjust this or edit this from the level blueprints. You just quite simply select it while in the level, go to your level blueprint, right click, and create a reference to it. And then you can start it, stop it, change the volume. You can have it speed up, etc. if you want to have more intense parts of the game, etc. Very straightforward way of adding some music. And then for sound effects, we're going to go sort of a general overview, and then you can go wild. You can add wherever you wish to. It's just to get the idea across, and where sometimes it's more effective to add them and what your options are, rather than taking you through every single possible option, because I don't think that would be the most efficient way of doing it. So first of all, our pickups. Now, super simply, after we've spawned the system, we can just pop in a play sound 2D and we can pick any sound. I've just picked one of the default sounds. It's the dockable window open. It was close enough to something that I thought would be relevant for a pickup sound. And by putting it in the blueprint itself, you can have it different for ammo and health if you wish to, or you can have them the same. You also have the option, and this is a slightly lesser known fact, of adding sound to your systems, your Niagara systems. So, although we haven't touched much on these, we're keeping it very simple. This won't stray from that very much. But in your particle spawn, when you click add, if you type in audio, you will see there is a play audio option. You can click on that, and then whenever it spawns the particle, it will then play a sound of your choosing. So that is another option that can be very useful if you're going to be using a single system for multiple different things, and whenever that system plays, you want that sound to play, or is a sound unique to that system, for example. So that is another option. And then, of course, um, on the theme of sounds when interacting, you can also have sounds attached to the enemies, for example. So let's go to our enemy character, and I've added or I've decided to add a sound when it dies. We have something that checks for when its health reaches zero. So essentially when it dies, we call the enemy killed, we will play the sound, and it's a fire and forget. So you can play the sound, it'll play once through and it'll delete itself. So you don't need to worry about it taking up too much space, etc. Because we're not spawning a sound, we're just playing it once through. If you pull this drop down, you can get some of the options again, your volume, let's zoom in there, your volume, your pitch, your start time, etc. Don't worry about concurrency. And the is UI sound just makes it so that there is no attenuation, so the distance, etc. doesn't matter. And also UI sounds can play even when the game is paused. Um, Probably the most important thing. So for now, I've just popped it in there. So when the enemy dies, it'll be this sound. I've chosen Start Simulate, and then it will destroy the actor, as well as having a sound for when the projectiles actually collide with the enemy. That kind of auditory feedback can be very satisfying for a player. They're going to have the haptic feedback already built in for when they're firing the gun, but it can be very nice to have the sound play when they actually hit the target as well. and you can change it for whether they hit the enemy or whether they hit the ground, etc. But for now, I've kept it nice and simple so that when they hit the enemy, there will be a sound, or essentially when the enemy loses health. So it's a projectile hitting the enemy, not something else. And when the enemy dies, there will be a sound. And those are sort of the very basic ideas of what you can do, where you can add in sound, you can add in some footprints, etc., or footsteps rather. But in VR, etc., that's usually a little bit more complicated, but it is a nice idea. You can have other ambient sounds coming from specific areas as well. So the last thing I want to touch on is sounds at locations. So let's look at the enemy and go back to the play sound if hit. Here I've chosen play sound at location. Now all that changes is that, so you'll see if we pull it down, just actually move this to an area where we can see it a bit more easily. So if you pull it down, you'll see that now, because we've got sound at location, we have attenuation settings. If you are not familiar, attenuation is essentially how sound changes or distorts over distances. So, for example, the further you are away, the softer the sound gets. Is a very basic version of it, but not all attenuation is linear. So that can just help for giving a sense of distance and a sense of depth to the game, but that's not necessary. I like to have place sound at location for things that I want the players to be aware of the distance. So, for example, you're hitting an enemy, but the enemy's further away. It's not going to be as loud as when you hit the enemy right in front of you, for example. So those are your two options. You have your 2D sounds, your play 2D sounds, and your sound at location. There are obviously many more options, but those are more than enough to get the auditory experience across to the player and make it a much more interesting experience. All right. So let's move on to one of the more interesting parts of this tutorial, sort of a little bonus as well. So we want to now, by completing our game loop, we want to have a main menu, something that greets the player when they start the game and gives them an idea of what's happening before they enter the game. Now, for the sake of this tutorial, we're going to discuss one of the methods of creating a menu, and for VR, I find it one of the more satisfying and interesting methods as well. So the first thing you'll want to do is you'll want to go to File, you'll want to go New Level, and you'll want to select an empty level, and then click Create. I have already gone ahead and done this. I've called it Main Menu Level. Let's go ahead and open this, and you'll see inside, very simply, I've just added a floor, essentially a player start so that the player knows where to start, and then a button with a light that simply just illuminates the area. Kept it super, super simple. For the sake of this, want the player to arrive, be greeted by a nice big start button, which they'll be able to actually interact with physically. They'll be able to push the start button down, and then when it reaches the bottom of its motion or allowed motion, it will then begin the game. And you can obviously increase as you can have your start, your options, your quits, etc. You can have a bunch of different things. You can pick your levels, but this is a really fun way of getting into that. And since we've already discussed widgets, and the VR template does come with a menu attachment that when you press the menu button on your left controller will pop up above your hand. I thought this would be a nice fun way of addressing an alternative way of dealing with widgets and menus, etc. And in VR, this is sort of a very unique way of doing it as well. So first things first, let's go into our UI and let's take a look at our button. So to create the button, it is quite simply Blueprint class and an actor, and I called it Blueprint button. And the button itself is essentially made up of 4 components. 3 of them are much more important than the other. So we have a simple cube static mesh, which makes up the button itself. You can shape that however you wish to. For the visual feedback, I've simply added a text render. So if you go add, you type in text, you get a text render. You just simply orientate it so that it sits on top of the button like as such. On the right hand side, you can type in what you want it to be, and a couple of other settings there. None of them are particularly important for what we've done here. Most of them are just quality of life. And then probably most important, a collision box, which sits just above the cube. This collision box will be detecting the player's hand for the interaction component of this. And this box, very straightforward. All you need to do with this box is adjust its shape and size so that it sits just above the button, but everything else is bog standard. Nothing interesting or different there. And then finally, a very nice visual representation for this is you want to have an arrow that essentially acts as the distance gauge. So the bottom of the arrow will be the bottom of the button itself. Now, initially, when you put the arrow in, the bottom of the arrow will align with the button. That's perfectly fine. This will change when we go into the construction script and we set that up. So you might have it so that the okay, I actually can't change it now because of the construction script, but you might have it so that the top of the arrow, the head of the arrow sticks out. That's perfectly fine. Don't stress about that. We will come and change that soon. So speaking of that, let's go into the construction script. So the construction script is essentially the script, the set of code that fires off whenever a change is made to the blueprint or whenever the blueprint is introduced to the level. So the construction script is essentially the setup script. It's different to begin play because begin play will run after the game is actually started. The construction script is set up before the game begins, before anything like that happens. So you'll see if you have a construction script that updates or almost randomizes things every time you move it in your editor, every time you start a new level or whatever, it will run the construction script again. So for the sake of this, we need one new, or sorry, two um, variables that we'll be adjusting. So the one we create is just the button offset. This is essentially going to be the variable that controls how far the button can move. And this will decide how long the arrow is going to be. So we take our arrow, we drag it out, we type in set arrow length, and we get this set block, and we plug our button offset into that. Then from there, we want to take the button and we want to set the relative location of the button, and it will initially come as a combined node or pin, which will be transform. We want to split that, so we want to right click. So let's do an example. So let's just find get active transform. If you right click on this, you will see split struct pin, and then it will break it down into its constituents. So we want to only have the new location Z because we only want it to go up and down, and we're going to plug the button offset into that. So that is essentially setting the arrow length and making sure that the button is at the top of the arrow. So once this script has been put together, your button should look as such with the bottom of the arrow exposed underneath. And because of the construction script, you won't even be able to move it, given that every time you try and make a change, it sets the button offsets the distance the button is from its origin to the length of the arrow, and that is all defined by our button offset here, which initially, once you've compiled, you can just set that value to 50. It's a pretty conservative amount. This has more to do with how far you want the button to go before it, in inverted commas, clicks, before it is activated. I chose 50 because it felt a countable number. You can go shorter or longer. So now that we've handled the construction script, you want to actually see what the button does. Now, a little bit more to this. Let's remove this. A little bit more to this. So the first thing is we want to make sure that it detects for overlaps. So on our box, as before, you scroll to the bottom, you have your on component begin overlap. We're going to have one of those, and our on component end overlap. We're going to have one of those. So for the begin overlap, we are checking that the component has the tag hand. So we only want to work for the player's hands for any time this button shows. Should that be true, we have a successful overlap, which we have as a variable, and you'll see why now. And then when the hand leaves the box, so when it leaves that collision area, making sure it is the hand, we then end the overlap. So where that becomes important is at event tick, it is constantly checking to see if there has been a successful overlap. And if there has been, uh, it will then begin to actually move the component of the button. So it will move it relative to the hand. Now, to make that happen, we want to find the relative location of the button itself. We only want the Z again, and we're going to adjust it by 3. So that's essentially the speed at which the button depresses. It can't go down any faster than that as there is pressure applied or as the hand collides with the box collision. The fastest it can go down is at 3 per tick, and we want to make sure that it doesn't go any further than our button offset, then essentially the distance that we've chosen before the button activates. So we use a clamp float. Our min is 0 because that's obviously where it's going to start, and our maximum is our button offset. And this will define the target relative location for our move component 2. And just to make sure that it feels nice and responsive, we want to make sure that the time over which this activates is very, very small. So 0.001 is more than enough or perfectly fine. And then we want it so that when the overlap is not happening, the button should actually reset itself. So we quite simply just copy paste all of this and we change the minus, so the button going down, to plus so that it comes back up. Everything else stays the same. And then the last thing in our event tick is for the second in our sequence, we want to check that when the button hits relative location 0, so because remember it starts at the top of the arrow, so it starts whatever the button offset is above your endpoint. When it reaches that endpoint, we want it to do something. So because this is a start button, I have it set up so that when it is true, it will call start game, which is an event dispatcher, which will send to the level blueprint, and it will then run that function. So the only other thing we need to change is the VR pawn because it is not initially set up to interact with such things. But fortunately, that's very simple. So we move over to the VR pawn. On the left-hand side, we find our controller. We want to make sure that it is the motion controller right, not the aim. And we quite simply, so let's just zoom in here. We quite simply want to select that and we want to attach a sphere collision to this. We want it to be quite small. We want it to be just around the actual hand itself because these are represented as hands in this version. The sphere radius of 12 seems to be quite nice. So on the right hand side, once you've selected your sphere, you'll see under shape, there is a sphere radius. I think the default is 32. We want to change that to 12. And that is a nice sort of comfortable range. And then we want to make sure that that is set up for the motion controller right as well as the motion controller left so that you can press the button with either hand. And that's quite simply it. You don't need to change anything else in the VR pawn. Everything else will act as it normally should. So the last thing we need to do is we need to make sure that when the start game event dispatcher is called, that the level blueprint actually knows what to do with it. So for the main menu level, we go to open level blueprint. We at begin play, because the button is already in the level, we call a reference to it. So just to recap, you select it, you go into the level blueprint, you right click and create reference to BP button. This will only show if the actor is selected in the level view in the editor. If it's not selected, you'll see there will be nothing at the top. So with that reference created, we want to assign, so assign or bind, assign just usually a little bit quicker, assign to start game, and we want to have a start game event. And for this, super simple, all that's going to happen is once the start game event starts or is activated, we are going to open our wave shooter level, the main level that we have set up, and then we will begin playing. And that is it for our menu. So very, very basic, but a very fun, interactive way. You can fiddle with it a little bit. You can give it some nice sounds. You can make it feel like it clicks a bit better. Most important thing is that this is what's going to first greet the player. You can add a lot more into it. You can add some information about the game. You can add a little board in the back, whatever the case is. But with VR, you really have the space to be a bit more creative. And it's always advisable to really leverage that side of VR to ensure that it actually feels more interactive rather than just clicking and pointing like you have a remote, etc. Although that can be quite satisfying and interactive, this is a sphere of VR that I think is unique and we should really be leveraging it more. All right, so now that we've gotten through the rest of the tutorial, let's wrap things up and let's take a look at some improvements and changes that would or could be made to this game going forward. So one of the first ones, one of the most obvious ones, is building out the scene, giving it a theme, actually making it feel like a level from a game rather than just a prototype level as it currently is. Things like mega scans, using Quixel Bridge, etc., can be very useful. And as such, you can use these free assets as well, as long as you have an Epic Games account, to build out your levels, your scenes with various different themes and very high quality assets that can also be simplified to work for VR quite nicely. Then, of course, currently it's all happening on one level other than the main menu level. And although there are different waves, etc., having different levels that have different challenges, maybe some navigational challenges, maybe it's all static, maybe you're always behind a bench or in a little bunker, etc., and the enemies are trying to break that down. Having some different levels, having some variation can really improve the game experience. Better HUD, better heads-up display can always be applied. It's always something that can be added as well, whether that's changing how it looks, giving it some nice little details and frills, changing it completely, or even adding in more information, etc. That can also be done. Then the enemy AI, very simple for now. It has some, they're not bugs, but given its simplicity, if you play enough, there will be some stranger things that happen that don't necessarily seem to make sense. Like, for example, the enemy might, depending on how you have your collision set up, might be standing right next to you and you're, losing health, etc. But then they run off and go into a different direction as if they don't care about their initial order. That can be adjusted, that can be changed. You can change the retriggerable delay, you can remove it entirely. That can be up to you depending on what kind of game it is you want to create. And then, of course, on top of that, some enemy variation. So currently all the enemies look the same, and what they do is they just run towards you, and then they essentially damage you by moving into. So contact based enemies, which is fine and it works for the game loop. It's not super exciting. Maybe giving them different speeds, different sizes. Some do more damage than others, but they're slower. Maybe if you want to add in some shooting, etc. So give them projectiles or weapons of sorts. You can use a very similar setup as well. So fortunately, it's not too complicated. The difficult part is just making sure that they're shooting in the correct direction and they have you can whether or not you want them to have ammo, etc. So some variation can really help. Then giving the player options for how they move. So currently it's all teleport based, which is the default, straightforward to set up, and has very few or very little to no motion sickness involved. You can change it so that the joysticks on the controller, if you're using something like the touch controllers from Meta, then you translate similar to a controller or an FPS, where as you move the left joystick, it moves the character. Just be very careful of motion sickness there. But that is an option, giving the player some other kind of locomotion, or taking away locomotion entirely and having them static in a specified space, so that as they move in their real space, they move in this small space, allowing them to pick up ammo, etc., in the area around them. Similar to something like Arizona Sunshine, I believe it's called, where you have your zombie waves, etc. And then lastly, your projectile variation. So currently, the projectiles are very straightforward, but they don't go very far. You can change that. You can change the gravity scaling on them. You might want to replace them entirely, maybe different kind of bullets, something like a laser, etc. That can all be adjusted to make a more interesting experience. And maybe you can pick up things that change what kind of projectiles you're shooting. Maybe it's doubling the projectiles, something a bit more roguelike, where every time you reach the end of a wave, you get an upgrade or something as such. So those are all things that can be considered, all things that can really add to the game, improve it. Obviously, your main menu, etc., can always be improved. But for the actual game itself, the actual game loop, these are things that I think if you want to take this tutorial to the next level, you want to take it to a stage where you actually have a game that is playable, publishable, etc. These are things you definitely want to focus on. But other than that, that is the tutorial. Thank you very much for joining me on this journey. I hope you learned a lot, and I will see you in the next one.